Good morning, students. Welcome to the online classes for Standard 9th Physics. Today I would start new chapter 9th of your NCERT textbook, Force and Laws of Motion. In this chapter, we will discuss basically the three important laws of motion postulated by Isaac Newton. You will find in your textbook first dealing something about Newton's first law, then second law, and then third law. But I will change the sequence a bit. I will give first the focus on second law. And then we will discuss first law and then third law. But before discussing Newton's second law, it's important to know about a physical quantity, that is momentum. This is a new physical quantity whose symbol is P. And it is defined as the product of two important physical quantities. One is mass and second one is velocity. So I can write the momentum P is equal to m into v. This is the definition, this is the formula for momentum. This is the meaning of momentum. For a body to possess some momentum, it must have two things. It must have some velocity, it must have some mass. Now, students, velocity is a vector quantity. It has some direction. Mass is a scalar quantity. So, momentum is also a vector quantity. So, momentum P is a vector quantity. First point. Second, if it is vector quantity, what will be its direction? So, it has same direction as the direction of velocity. If an object is moving towards right, momentum will be towards right. If the object is moving upward, momentum will be also upward, and so on. So momentum has the same direction as that of velocity. Third, regarding its SI unit. It's easy to see, students. Mass has SI unit how much? Kilogram. And velocity has SI unit meters per second. So if we multiply these two, we will get the SI unit of momentum will be how much? This multiplied by this, that is kg meters per second. This is the meaning of momentum. So based on this, let's do a question, simple question. Which has greater momentum? A bullet of mass 40 gram moving at 25 meters per second, or a football of mass 500 gram moving at 2 meters per second? So we will calculate for bullet and for football separately. Now for bullet, what is the mass? 40 gram. So mass is 40 gram. 40 gram can be converted into kilogram by dividing by 1000. And its speed is how much? 25 meters per second. So V is equal to 25 meters per second. Knowing m and v, can we find momentum? Yes. So momentum of bullet, which I'll call as P1, this I'll call m1, this I'll call v1. So product of mass into velocity, so m1 into v1. So this becomes 40 upon 1000 multiplied by 25, and the SI unit will be how much? Kg meters per second. So 1 0 will cancel, then 25 into 4 is 100, and 100 by 100 will become how much? 1 kg meters per second. Likewise for football, what is the mass? Mass of the football is 500 gram, that means 500 by 1000 kilogram, that is half kilogram. and its speed v2 will take as how much? 2 meters per second. Therefore, its momentum p2 is the product of m2 and v2. So this becomes half kg into 2 meters per second. So how much will we get? 1 kg meters per second. So both of these, the bullet as well as the football, their momentum we find that is same. So therefore we'll write both the bullet and the football have same momentum. You can write the language yourself. So what do we find, students? Momentum depends upon both mass and velocity. The bullet is light, its mass is less, 40 gram. Football is heavy. If they have same speed, which one of them should have greater momentum? Football. But here, although the mass of a football is more, its speed is less, 2 meters per second. Whereas, bullet which has smaller mass has large speed. So, momentum depends upon the product of mass and speed. Only by knowing mass or only by knowing velocity, we should not judge about momentum. For example, train. A train is very, very heavy. That does not mean it will have large momentum. Its momentum will also depend upon its speed. If you have a long train which is very, very heavy, its mass is very, very large, but if it is at rest, what will be its momentum? Momentum will be m into v. M, although it is very large, but the speed of this train is very small, not small, just 0. If the train is at rest, its speed is 0, so momentum is also 0. So remember, students, you have to incorporate the product of mass and velocity to judge or to find the momentum. A light object may have a very large momentum. At the same time, a very heavy object may have very small momentum, depending upon their speed. Okay. Likewise, simply having large speed does not mean the momentum will be very large. The momentum will be large if both of them, or you can say the product of mass and velocity is large. Okay. Okay. Let's now discuss Newton's second law of motion. We will confine our discussion to a straight line motion. Suppose this is a straight path, and on this path there is an object. Suppose the object is somewhere here at point A, and it has some speed. That speed is, I call it as u. So u is its initial speed or initial velocity, I can say. If force acts in the same direction, you can see the speed or the velocity is towards right, force is also towards right. If force is towards right, after some time its velocity v will increase. That is obvious. You must have felt, students, if your friend is riding a bicycle, for example, on the road, and from behind you push his carrier of the bicycle in the same direction as the direction of motion of the cycle. So what do you observe? His cycle starts moving faster. Same thing I am telling. If you apply a force in the direction of a velocity, initial velocity, then the velocity of the object will increase. Suppose this force acts for time t. F acts for time t. In time t, the velocity increases from small value u to large value v. Now here what will be the momentum? Momentum at this point I will denote by pi, and at this point I will denote the momentum by pf. And what will be their values? You know, momentum formula is product of mass and velocity. So pi is mass of the object times its velocity. Velocity is u. And at this point, which I will call as b, this is initial point I, this is final point f. Here the momentum will be mass times v. Now tell me, students, out of these two, which is greater? In this situation, which I call as figure A, pf is greater than Pi. Why? Because I have discussed V is greater than U. Why? Because F, the force F, acts along the direction of motion or in the direction of velocity, or you can say motion. Let's see its opposite case. In the opposite case, suppose there is a straight line path, and then we will take 2 points. First, suppose the object is here, it was having some velocity which we will call as u. So its initial momentum will be how much? Pi is equal to m into u. Now suppose force on this object acts in opposite direction, and this force again acts for some time t. So acts for time t. Now imagine that your friend is riding a bicycle, he is riding the cycle, and you apply a force in opposite direction. Your friend is riding the cycle in right direction, and you hold his carrier of the cycle and pull it towards left. So this is the direction of force and this is the direction of velocity. This force you are exerting, he was earlier moving with constant speed, suppose v. Then what would happen? His velocity will remain same. Will it increase or will it decrease? Since force is opposite to the direction of motion, you will find that the velocity goes on decreasing. So velocity will decrease. Okay. With this in mind, after some time we say, suppose at this point the velocity will become smaller, and that will have some value v, and here the momentum Pf will be how much? M times v. All these three things we can write again in the context of second figure. First one, that force F, it acts opposite to direction of velocity, number one. Because of this, the final velocity v will be smaller in magnitude compared to initial velocity. If it has not stopped, see, there is a possibility that it will stop after some time, and if you continuously apply a force, the body may start moving in opposite direction. Earlier it was having motion towards right. If you apply continuously a force towards left, slowly its speed will decrease till it becomes 0, and after that it will start moving to the left. But I am considering that part of the motion wherein its speed has not yet reduced to 0. So its final speed after small time t will be less than u, and its final momentum will be less than initial momentum. Now see these two results. Here also momentum has changed, here also momentum has changed. What is the cause of change in momentum? There are two causes. One is the force itself, and second one is the time for which the force acts. If we apply a force in the same direction but for a very small time, suppose 1 second, then yes, there will be increase in velocity, there will be increase in momentum, but by a small amount. But if we apply the force for a longer duration of time, then the speed will increase to a larger value after that time, and therefore momentum will also increase to a larger value. So what we find? We find that the change in momentum of the body, change in momentum means final momentum minus initial momentum. So this I will represent by delta P. Delta means change. So what I told? It will depend upon time, where t is the time for which the force is being applied. Okay. Also, change in momentum of the body, delta P, will directly depend upon the force. Suppose one person applies a very large amount of force. If you apply large force, the change in velocity, the change in momentum will be large. But if you apply very small force, the corresponding changes will be very small. So these two are the factors on which the change in momentum depends. Now from these two equations, what we can write? If we combine these two, I can write the change in momentum which is delta P, should be proportional to the product of these two, F multiplied by T. And if this is so, I can write change in momentum, T will come this side, divided by time is proportional to force F. And it is this which was postulated long back by the famous scientist Isaac Newton and is popularly known as Newton's second law of motion. So let's see what does this statement say. So here goes the statement for the Newton's second law of motion. So Newton's second law of motion states that the rate of change of momentum. What is the meaning of rate of change of momentum? Change in momentum you have understood, students, that is delta P, that is final momentum minus initial momentum. If you divide that change by time, that becomes rate of change of momentum. So rate of change of momentum means change of momentum by time, that is delta P by T. This quantity in left hand side, that is rate of change of momentum of an object, is proportional to the applied unbalanced force in the direction of force. I have told momentum is a vector quantity. So change in momentum is also a vector quantity and it has the same direction as the direction of force. If we apply force towards right, in upward direction, if we apply force in upward direction, the change in momentum will also be in upward direction. That is the meaning. Now let's elaborate this particular point. So the change in momentum, rate of change of momentum, is nothing but change in momentum divided by time. This is found to be directly proportional to force. Without any loss of generality, you can also write force is proportional to change in momentum by time, means the same thing. So we can write F proportional to change in momentum, means I have told final momentum Pf minus initial momentum Pi by time we have taken as T. So this implies force is proportional to, now what is the formula for momentum? Mass into velocity. This is final momentum. So final velocity we will write as V. You can consult the previous figure which I have discussed just now, minus Pi is initial momentum. So mass into initial velocity, that is U. And then we will have divided by T. If we remove this proportionality symbol, then we will get F is equal to some constant times mv minus mu upon T is equal to m, you can take common. So we will be left with v minus u upon T. But what is v minus u by T? That is defined as acceleration. Acceleration is defined as rate of change of velocity. So v minus u by T is your acceleration. Therefore, what does force become? Force becomes F is equal to K times M times A. Very important relation. Let's see their units. Mass, you know, students, it has SI unit kilogram. Acceleration has SI unit meters per second square. Here this constant K is dimensionless. Dimensions probably might not know, but you should understand it is unitless. It does not have any unit. It is a constant which does not have any unit. See, there can be a constant which has unit. Constant does not mean it does not have unit. It is a constant and it is a unitless constant. It does not have any unit. Force SI unit will be product of these two, kg meter per second square, that is also called as Newton. When you write Newton in words, your n must be small, but when you write its symbol, that n must be capital. Let us first define Newton. Definition of Newton. Newton is the SI unit for force. We need its definition. its definition is like this: 1 Newton is that value of force which when acts on a body of mass 1 kilogram produces in it an acceleration of 1 meter per second square. So this is the definition for Newton. 1 Newton is that value of force which when acts on a body of mass 1 kilogram produces in it an acceleration of 1 meters per second square. If there is a body of mass 1 kg and if we apply a force such that that body accelerates at 1 meter per second square, then the force which you are applying is how much, students? That is 1 Newton. Now if you put these values in this equation, force will be 1 Newton, K is K, M is how much? 1 kg, and A is how much? 1 meter per second square. I am putting these values of mass, acceleration and force in this particular expression. So I have discussed kg meter per second square is nothing but Newton. So this Newton kg meter per second square will cancel. So what will be left? 1 will be left, and here k is there, and again 1 will be left. So k into 1 is nothing but k. So this gives us the value of k is how much? 1. If k becomes 1, this equation number 1, we can write it as F is equal to m into A. Equation number 2. So please see these things very carefully. So this is your mathematical formulation for Newton's second law of motion. Clear? So there are two ways of writing it. So earlier we were adding proportionality symbol, and that constant which we have used, k, the definition for Newton is chosen in such a way that this k value comes out to be how much? 1. So our equation becomes F is equal to m into A. If you put k is equal to 1 in this equation, then you will get another equation, that is F is equal to mv minus mu by t. mv minus mu by t. What is mv? mv is a final momentum. So I can write it as pf. What is mu? Initial momentum. I can write as pi by t. So this is also mathematical formulation for Newton's second law of motion. The equations 2 and 3, let me write that. Both these equations number 2 and 3, they are mathematical form for Newton's second law of motion. Is it clear, students? So this is all about Newton's second law that I wanted to discuss. This is the mathematical formulation. So remember, 1 Newton, which is the unit for force. So 1 Newton is same as product of these two. Product SI unit for mass is kg. So I can write 1 kg into acceleration is how much? 1 meter per second square. So 1 Newton is, I'll write 1 kg meters per second square, and this is reflected in this definition, that if there is a body of mass 1 kg and it accelerates with an acceleration of 1 meter per second square, then the force on the object is called as 1 Newton. Let's do a simple question based on Newton's second law of motion. This question reads like this: a car is moving with a velocity of 108 kilometers per hour. So this is the initial velocity. It takes 4 seconds to stop after applying the brakes. Calculate the force exerted by the brakes on the car if mass of the car along with passengers is how much? 1000 kilogram. Let's write given things first. The initial velocity u is how much? 108 kilometers per hour. You know, students, how do we convert this in meters per second? So this becomes 108 into 5 by 18 meters per second. Calculations, students, I'll suggest you to do yourself. I'll just discuss the method. Then it takes 4 seconds. So time is given 4 seconds. to stop. That means finally the car is stopping. So what should be its final velocity? It should be 0. Clear? Calculate the force. So one more thing is given, 1000 kilogram as the mass. So m is how much? 1000 kilogram. So to find, what you have to find? Force F is equal to question mark. So we will use Newton's second law. From Newton's second law, force is equal to m times A. But A is not given. So I have told you there are two forms. So instead of using this, I will use this form, mv minus mu by t. So I can take m common and I can write v minus u upon t. You can also understand this from this form, m times a, but acceleration is v minus u by t. Is equal to, mass is given how much? 1000 kilogram. V is how much? 0. U is, you will calculate this, t is 4 seconds. Because it is 0 minus something, on calculating you will get the answer in Newton and you will get a negative value. Minus something in Newton you will get as the answer. What does this minus sign indicate? So whenever your acceleration or force comes out to be negative, it means it is in a direction opposite to the direction of motion of the car. So your car, if it is moving towards right, on applying brakes, the force is applied by the road on the tires in opposite direction. So here you should write one statement that negative sign indicates that the force is directed where opposite to the direction of motion of the vehicle or the car. Is it clear, students? Okay. Okay, students, I will stop here for today. In the next class, I will use Newton's second law of motion to explain Newton's first law of motion. And for till then, you please read Newton's second law of motion carefully from your textbook and from the notes which you will make based on what I have discussed today. This will be your homework, students, from your NCERT textbook examples 9.1 to 9.5. These 5 examples you will do it yourself. These are already solved in your textbook, but based on the discussion which I had today, if you are sincere, you will be easily able to do these questions. If at all you find some doubts, only then try to see the solutions, and after you solve it yourself, please match the answers. And in case you have queries, you can put them in the link provided in your school's website. So till then, thank you, students. See you in the next class.